Article topic: The ecomorphic aspect of the soil macrofauna community transformation under recreational impact. Soil has natural protective properties. Therefore, even under conditions of intensive anthropogenic impact, the soil macrofauna maintains a high level of abundance and diversity. Urban parks perform a wide range of ecological functions, many of which are due to the activity of soil macrofauna. Assessment of the transformation of soil macrofauna under the influence of recreation is important for the creation of effective urban environmental management strategies and environmental monitoring systems. The aim of the study is to identify the main trends in the transformation of the soil macrofauna community under the influence of recreation and interpret them using the ecomorphic approach. Soil macrofauna were collected under conditions of varying levels of recreational exposure. In addition to soil animals, soil properties were measured and vegetation was described. The results obtained on the community structure were subjected to ordination. Some ordination axes were strongly correlated with distance from walkways, indicating their response to recreational pressure. The various aspects of variation in the soil microfauna community are related to the restructuring of the ecomorphic structure. Research aim and objectives. An important scientific problem is to investigate the possibility of applying the ecomorphic approach to assess the impact of recreation on soil biota. We tested the following hypotheses. 1. The community of soil macrofauna in the recreation zone is organized due to the relationship with environmental properties and the structuring of ecological niches of soil animals. 2. The ecomorphs of soil animals are informative and important characteristics of the ecological properties of the macrofauna, which can explain certain aspects of the structuring of the soil animal communities under recreational conditions. Model polygons of public green spaces in Melitopol. The study was carried out on the territory of Park Novoalexandrivskoye. We laid a polygon with a moderate level of recreational load with an average distance to the spontaneous walkways of 4.1 meter. Standard deviation was 3.2 meters. The polygon was a set of 105 sampling points, which were collected along 7 transects placed in parallel, with 15 sampling points in each transect. The distance between the closest transects was 3 meters and 3 meters was the distance between the closest sampling points in the transect. Thus, the sampling points represent a regular grid with a lag of 3 meters of 7 times 15 sampling points, 21 times 45 meters. 35 soil animal species were found in the study area. The abundance of the soil macrofauna community was 493. 10 Indiana/M2. The earthworms were the most abundant and diverse group of saprophagus within the study area and were represented by 3 species. The abundance of the earthworm community was 73. 18% of the total macrofaunal abundance. The endogic species Aporectidia trapezoides dominated the abundance of earthworms. The population abundance of this species was 292. 27 Indiana/M2. Together with this species, Aporectidia rosea was also represented by endogic earthworms and Dendrobina nasinovi was represented by anistic earthworms. The abundance of earthworm cocoons was 23. 31 Indiana/M2. The hygromorphs of earthworms were represented by Xerophilus and Mesophilus species. Among the earthworms there are pratons and stepants. The basis of the xenomorphic structure of soil macrofauna in terms of the number of species was represented by sylvants, 47.1%, and pratons, 23.5%. The proportion of stepants, 26%, and paludants, 8%, was somewhat lower. By abundance the situation was somewhat different. The basis of the xenomorphic structure of the macrofauna was represented by pratons, 64.0% in abundance, slightly fewer stepants, 19.0%, and sylvants, 16.8%, and occasionally by paludants, 0.2%. Projections of ecological niches of soil macrofauna species on OMI1 and OMI2 axes. Lower part has negative axis values, upper part has positive axis values. The vast majority of the species on the above lists should be noted to be litter-dwelling species, but at this stage of the analysis it is very difficult to come up with a hypothesis that would explain the observed ordination of species in the community. The RLQ analysis found that 91.24% of the total variation, total inertia, described the first 2 RLQ axes, 84, 19 and 7.05%, respectively. The Rantist procedure confirmed the significance of the RLQ analysis results at a peer level of 0.017. Conclusion: the ecomorphic organization makes it possible to interpret trends in the variability of the soil macrofauna community under conditions of recreational pressure, and to explain the spatial patterns of the soil macrofauna. The ecological space of ecosystems under recreational conditions is structured between ecological niches of the soil macrofauna. The marginality, tolerance and residual tolerance quantify the position of ecological niches in the ecological space. The variability and soil properties, which is induced by the natural factors or recreation, is a driver for structuring the ecological space of soil macrofauna. The soil animals are the most sensitive to variability and the soil penetration resistance, soil moisture and electrical conductivity. There is a relationship between environmental factors in public green spaces, the structure of the soil macrofauna community and its ecomorphic organization. The ecomorphic aspect of the structure of the soil macrofauna community is more sensitive to recreational pressure than the distribution of ecological niches between species in the ecological space, which suggests that the restructuring of the ecomorphic community structure is a condition for the stability of its organization. The natural variability of soil conditions within the ecosystem manifests itself in changes in the ratio of xerophiles, phytophages, carbonatophiles on the one hand and pratons, paludans and hypercarbonatophiles on the other. A lower level of recreational load is favorable for saprophagus and decarbonatophiles. The zoophages, hemiaerophobes and megatrophocenomorphs are tolerant to high levels of recreational load. The area that corresponds to the highest level of the recreational load is vacant. This indicates that the most transformed areas are randomly inhabited by representatives of different ecological groups.